So actually, this is first stage of the publication. We prepared this conference to promote entrepreneurship education in Korea and as well as Asian countries. Actually, participants are from all over the world, and we have some participants from United States and also Europe and Africa. I don't know, but we have many participants from Asia too. Okay. Well, this Re-Asia, Re-Conference, SLV conference, we have the conference 4 times a year, actually. Once in Europe, and once in Latin America, and in Asia, and America too. Tina Sillik, she's the Jongmun-Lee Executive Director of Stanford Venture Program. She's actually the host of our conference. She'll come forward and explain about the Re-Accelerate. I'm sorry. Okay.
Hello, everyone. It is my sincere pleasure to welcome all those people I haven't yet met. This conference is really very, very important to entrepreneurship educators around Asia and around the world. RE is officially the Roundtable on Entrepreneurship Education. And this is an opportunity for the leading educators in entrepreneurship in different regions of the world to come together, to learn from each other, to talk about best practices, and to build a community where people can work together outside of the conferences after they're over. This conference in Asia is the 4th one. We've also met in Singapore, in China, and in Thailand, and we have meetings scheduled going out until 2010. Next year we'll be in Australia. The year after we'll be back in Thailand, and after that we'll be in Hong Kong and in Shanghai. We are very excited about this. We also host conferences in 3 other continents, in the United States, in Europe, and in Latin America. And I invite all of you, if you're interested, to learn more about this at our website, which is ree.stanford.edu. So welcome. It looks like a fabulous program today. And thank you very, very much to our wonderful, fabulous hosts from Kaist.
Thank you so much. Actually, our students prepared some, the animation, video clips. So let's watch it for a few minutes, okay?
There are periods in one's lifetime, such as the thought of being alone freely. However, being alone does not necessarily mean being lonely. Better alone living a little meaningful life. Living with someone for whom there is no trust, no understanding, no communication, no job.
Thank you so much. Well, actually, I have to introduce myself first. Okay, I'm the director of Center for Entrepreneurship, Science-Based Entrepreneurship at Kaist. I'm the host of the conference. But anyhow, you probably felt that our students helped us were fabulous. But actually, I never said any words to do what. Okay, but they made their own decisions and they planned and they even prepared this video clips. Let's give a big hand to our helpers. Okay, let me introduce our today's program very briefly. And okay, today we will have 2 keynote speeches after our welcoming address from our President Nam-soo. And then after that, after the 2 keynote speeches, there will be a panel discussion. And after that, we will have a Samsung lunch next room. We'll move to next room, and then we will be back for the afternoon session. I will be leading the morning session, but because of my physical limitation, I asked my colleague, Professor Chang, to lead the afternoon session. I will briefly introduce the speakers and program leaders right now. Okay. Firstly, our President Nam-soo. He's here, and he had a long travel from Switzerland this morning. Okay. So yeah. Would you stand up, please? Okay. Okay. And first big speaker is Professor Yoshikawa from Japan. I will introduce him later when he comes out for the keynote speech. Okay. Professor Yoshikawa. And Dr. Anand from IIT Madras. Okay. Panel session leader, Mr. Kokuryo, Professor Kokuryo from Keio University. Okay. Samsung CEO, he didn't arrive yet, so when he comes, then I will introduce him to the audience. And afternoon session, just before you met Tina, and Tom will be the speaker here. Okay, would you stand up? Tom Bayer from Stanford University. And then we have a video clip of Gopala Krishnan of Infosys in India. So I can introduce him here separately. And Byung-Hoon Lee of the Univera Corporation, CEO, he will come a little later. And afternoon session leader is Professor Chang. Professor Chang, Hyunjun Chang. We had long discussions about how to build up a better Asian network. So that thing was, Professor Casey Choi will lead it. Okay, Professor Casey Choi. Okay, do I miss anybody? Okay. And during the lunchtime, our former president, and currently he's a member of Korean National Assembly, Dr. Hong Chang-son, will come in. I will introduce him to you when he arrives. Okay. Okay. I will introduce my President, President Nam-soo. Actually, in Korean pronunciation, Seo, but he's very famous in United States. As goes by Nam-soo. Okay, so President Nam-soo, he's the current president, and he's the 13th president actually. So he joined our faculty last year. Professor Nam-soo graduated from MIT, and he started his faculty job since 1970 at MIT. Well, before that, he was teaching at the University of South Carolina. He held many positions at MIT. He was the director of the Laboratory for Manufacturing and Productivity, and also he was the head of the department head of the mechanical engineering for 10 years, from 1991 through 2001. Actually, he still holds his distinguished professorship at MIT, and he's serving as currently president of Kaist. He actually founded one company named Trexer, and he serves many board members in United States, and also more importantly, he served as a director of engineering at the National Science Foundation in the United States from 1984 to 1988. I think he had a deep impact on engineering education in the United States, and actually it had a good impact on world too. He had many honorary doctoral degrees from Israel and Australia and Sweden, and he had many prestigious awards. Let's welcome Dr. Nam-Soo, our president. Thanks.
안녕하십니까. 저는 소개받은 손학표입니다. 오늘 여기 외국에서 오신 분들이 많아가지고 제가 영어로 인사 말씀드리겠습니다. 양해해 주시기 바랍니다. Well, I was very proud to see what our students could do with all the logos of famous companies. I just hope that they'll send hefty bill to these companies because for showing all those logos at this conference. Anyway, I'm delighted and I'm very excited to be here with you. As Professor Yang,
I'm sorry, let me interrupt. Okay, I mean, today we prepared a simultaneous translation. If the Korean people, if you want to listen to Korean, then you can use it. And for the Korean speaking, the Americans, you can use the earphone translation. Thank you. Sorry.
So anyway, with that clarification, I guess I can speak in any language. So I'll mix between the two. So all of you may need earphones. Now, on behalf of Kaist, I'd like to welcome all of you from abroad as well as from other institutions within Korea. Certainly, I didn't expect so many attendees of this conference. When Professor Yang talking about this, I thought there may be about 50, but it looks like there are a lot more than that attending this conference. Certainly, that goes well with the reputation of Professor Yang, who is very energetic, very creative, and he has a way of dealing with a large number of people. And I'm constantly learning from him as to how to do these things. So anyway, I'd like to express my appreciation to my colleague, Professor Yang, for organizing this conference, and his team who made this possible. And also, I would like to express my special appreciation to Chairman Jung-Moon Lee, who is not here because he had to be in Washington, D.C., and he's undertaking a very special assignment there in Washington, D.C. So he sends his apologies to all of you for not being here today. And also, I'd like to thank my old friend here, Professor Yoshikawa, who was president of Tokyo University, and I had known him for a long time. He always had white hair. I didn't have white hair then. But anyway, we go back 30 years or more. I'm not sure how many years. But anyway, we have been colleagues professionally and also in international organizations and so forth. And I deeply appreciate my colleague coming all the way from Japan to attend this thing. And also, I'd like to express my thanks to our friend from India, Dr. Anand, for coming and then joining our team. And there are too many people here. And I'd like to obviously thank my colleague here from Stanford, who made time available to be here at this conference and also visit Kaist. There are so much I want to say about this whole subject of entrepreneurship that this conference is all about. But let me just divert a little bit tell you a little bit about what I did during the last few days, and actually last 2 weeks. I was in Switzerland attending Lyon Colloquium. Lyon Colloquium is a very small meeting. Altogether, there were about 25 people, some current presidents and some former presidents of various universities in the U.S., Europe, and Asia. And we discussed a number of different things about the future of universities and what globalization should mean to all of us in running universities. One of the things that became very clear during the discussion was that technology is very important and entrepreneurship is very important for the future of all of our nations and for higher education as well. So although the topic of the conference or the meeting, colloquium, was more on this globalization of higher education, it was very quickly recognized that for higher education institutions to be viable, it has to contribute to technology and to business enterprises. So I'd like to just dwell on a couple of points about what we mean by technology, innovation, and so forth. Obviously, entrepreneurship is not going to exist, especially in the high-tech area, without technology innovation. And one thing we often forget is that in order to have technology innovation, you need very strong research base in our universities. Only when we have strong research base in science and engineering and other fields that we end up having technology innovation. So the fact that universities like Kaist, MIT, University of Tokyo, Indian Institute of Technology, Stanford, and so forth, have strong research programs is a basis on which we can build entrepreneurship and technology innovation. So sometimes we forget that it is the existence of strong research base which is a prerequisite in having technology innovation. The second thing that often we do not recognize when we talk about entrepreneurial undertakings is that only places where new business can start, where new business can grow, and the new business can be taken over by larger companies and become bigger companies and so on and so forth, occur if we have an environment where our graduates, the brilliant graduates we produce at our institutions, want to remain and work there. And this point sometimes not very well recognized. That is, at Stanford, around Stanford, there's a Silicon Valley and high-tech companies. That's because that area happens to be a very desirable place to live and work. Same thing can be said about Boston, the city I'm very familiar with, and there again, people want to remain there, live, and this is one of the prerequisites of having an entrepreneurial city and where our students can prosper and so forth. So one of the things we are trying to do at Kaist is to make the area we are in, the Daejeon City, the science park around us, to be one of these places where it will be desirable to live, raise children, create business, and then hire future graduates of our institutions. So with that in mind, Kaist has undertaken many, many changes during the last few months, and I will not bore you with all the facts. But we have changed the internal operation of Kaist so that we can indeed take advantage of the support of the Korean government, Korean people, and make Kaist one of the best institutions in the world. It's a kind of major goal, a very difficult task that we set for ourselves, but we think it's doable, and we will do so. So first step in making Kaist one of the best institutions in the world was to make internal changes before we ask for outside help. And that's what we have done, and we are all working very hard to make this thing happen. But anyway, I'm not going to belabor this point anymore, and I'd like to simply say that we need new business, we need technology innovation, we need entrepreneurs who can deal with major problems of our society. Often we think of technology innovation, creating new business, simply in terms of economic terms. But it turns out that society as a whole, the entire world, needs solutions for 4 very pressing problems that we all must work together and then solve. One is related to energy, second one is environment, third is water, and finally sustainability. These 4 issues will impact the entire world in the years to come, and we need to solve them. The thing that's very exciting about these problems is that as we try to solve these global problems, we'll find that it creates new business, it will require new innovation, it will require new science, and it will create opportunities for our young people. And that makes this whole global issues very exciting. So one of the things we hope to do at Kaist is we hope to create a campus solely devoted to global issues in the years to come. And I call that EEWS. Energy, environment, water, and finally, sustainability. These are the 4 topics in which we like to do more research and create technologies and produce people who can deal with them in the years to come. I wish all of you a very successful conference, and I hope that today's session will be as productive as it was during the last 2 days. And again, I'd like to thank you for coming and hope that you enjoy your visit to Korea for those of you who came here from other countries, and for Korean people who are here, hopefully this will be the beginning of a long-lasting relationship and interactions between Kaist and your institutions. Thank you very much.
Okay, thank you, President Namsu. Okay. Well, actually, he has a very entrepreneurial mind. When it comes to Kaist, we, as an academician, I mean, we normally think about the normal curve. Okay, the center part is the large one, and put it aside. He put it. Okay, and then the U-shaped curve, and he demanded us to move one end, the academic excellence chasing for, or the other one for the actually practice excellence. Okay, so it's a pretty challenging thing, but I think a lot of professors are accustomed to that. That we are trying to follow instructions, and I think we are having a lot of progress. So if you have any questions about our Kaist policies of entrepreneurship of mind, then during the panel sessions you can ask him. All right. I think okay. All the 10 participants are very important people, but I'd like to recognize 2 more people. First one is Mr. Song Ki-jae Song from Dunsan Cluster Development Agency. He's the president of the cluster. Okay, would you stand up, please? Okay, Mr. Lee Sang-chun Lee, he is the president of the Changwon Cluster Development Agency. Okay, we had a lot of sponsors and supporters for this conference, and I need to recognize the organizations and the companies. Actually, the first one is COSI, Korea Research Council for Industrial Science something. Sorry, okay, there's a COSI. They supported us. They gave us a pretty excellent dinner Tuesday. And Ambex Corporation, the chairman is Mr. Jong-mun Lee, so they supported us a lot. And third one is Samsung Electronics. They will provide us excellent lunch today. And the CEO of Samsung Advanced Institute of Technology will come here and give us a talk, luncheon talk. And fourth, head of Innopolis, they served us an excellent dinner yesterday, and the president Park, he gave us a welcoming speech, right? And fifth is Woolin, that's the construction company, but they were very generous enough to help us. So tonight they're gonna take us to Korea House and show you the Korean traditional performances too. Yeah. Thank you. So let's give a big hand for sponsors. Okay, now we'll move to the keynote speeches. First speaker is President Hiroyuki Yoshikawa. Okay, Professor Hiroyuki Yoshikawa is currently President of the National Institute of Advanced Industrial Science and Technology, so-called Kaist. He was the president of University of Tokyo from 1993 to 1997. And before he became the president, he holds many different positions in the university as a dean and vice president. And he has so many honorary and leading, positions in Japan. For instance, he was the science advisor to the Minister of Education, Science, Sports, and Culture. And also, he was the fellow of the Churchill Hill College at the University of Cambridge. So there are so many things. So I want to reduce it. President Yoshikawa has several honorary doctoral degrees from Norway, New Zealand, United Kingdom, and numerous prestigious awards such as IFIT Silver Core Medal Education Award from U.S. Society of Manufacturing Engineers, and the Royal Honor of Merit from Norway, and 13th Japan Prize. He graduated from the Department of Precision Engineering at the University of Tokyo. So actually here all the presidents are the engineering backgrounds. Okay? Let's welcome President Yoshikawa.
So thank you very much, Professor Yang, for your very kind introduction to me. And it is my honor and privilege to have such a very important occasion to have a talk about innovation. And my topic is the science-based innovation. And people are discussing intensively and extensively about innovation recently. Maybe society is requesting new innovations. But I think today I will just limit my talk about science-based innovation first. So let me start with my talk with just a short history of innovations in Japan. And maybe recently we have started to discuss about innovations very extensively, but we can remember that in Japan there were some innovations in 1960s and 1990s. And people say that we had a very high, rapid economic growth in these times. That is owing to the development of the manufacturing industry. We have exported a lot of things to the worldwide, etc., etc. But mainly, for example, we can say a bullet train, which was inaugurated in 1960s, was a big innovation, I think. And the reason why we could make such kind of innovation at that time, maybe very simply we can say there were some basic knowledge of science and technology within university, I think. And of course at that time our budget was not so big for science and technology research, basic research, but there are professors in universities who study a lot worldwide and collected many important information from different countries. So there are some kind of a community where scientific research has been conducted. And also there were very good enthusiastic private firms to make something new. And at the same time, there was a big bridge between them to connect the basic research and application. And that is a very important thing, that we can say there was some kind of a special social mechanism. Just I would like to say one example. That is a National Railway Research Institute. And very enthusiastic young engineers and scientists come to research to develop new kind of train there. And that was the result. So maybe many engineers, not only from material, mechanical, but also from sociology, etc., etc. And many kinds of researchers come together to discuss about what will be the next train to be manufactured, to be made. And that was the billet train. So I think there was a very good space where such kind of very enthusiastic young researchers can come together to discuss about the future subjects in here. And that is a very good kind of connector or bridge between basic science and application. So I think there were some kind of a social mechanism within Japan to connect the basic research and application that is very important for innovation, science-based innovation. Oh, sorry. And now, because of some change of governmental policy in Japan, after 1980s, many national institutes have been privatized. And National Railway is not exceptional. National Railways have been also privatized. And they separated several companies. And then those national railway companies, private companies, have been exposed to very severe competition. And there were no room to maintain such kind of a basic research institutes, which was in 1960s. So I think after 1990s, I think there was no chance for national railways to invent new trains at all. So I think I would like to say there were no more social mechanism to make such kind of innovation. We can say another thing. But on the contrary, we have started 1996, that is a basic plan of science and technology. And we have invested certain amount of research money for basic science. For example, for the first time, 5 years, we have invested 70 trillion yen, and next 5 years, 24 million yen, trillion yen, etc., etc. So I think now the university professors are enjoying not a lot, but a certain amount of money to conduct basic research. So we are now in Japan creating basic research within the university or basic research institutes. And if you look at the private firms have become, I would like to say that they are now exposed to very intensive worldwide competition, and there are no room to maintain their own research institutes. So I think the distance between universities and private firms have become larger and larger, farther and farther, and we have lost the bridge to connect these two things. That is our problem. So what should we do? That is now the subject of discussion in Japan among Japanese people. Who will take care of the bridge which will promote innovation in Japan? And I can say very simply that maybe in 1960s and 1990s, maybe the players were public-private corporations based on national policies that address long-term development. But now, present, we have lost all of them. We have lost all of them. So now we need to construct some sort of network of excellence of national research institutes, such as AIST, that is our research institute, and this is wrong, this is WICAN, etc., etc. So those research institutes should take the role of bridging between basic research universities and private firms to actually create innovations. So so there are other things here. But when we think about the science-based innovation, we must be very careful that the innovation cannot be conducted only by basic research and applied research. We need some other kind of research activity in between basic research activity and application research activity. So this is just a very simple example. It was already 1985. Myself and a friend, Hungarian friend, Professor Hatvani, unfortunately he was died. He was dead. But we had made a very small project about the history of technology research. And we have found that usually when some scientists discovered very great discovery, had this great discovery, or epoch-making invention, maybe society will welcome them and applaud them, and also so people's reaction will be very good. And at the same time, the society, people expect the result of such kind of big scientific discovery will benefit society very soon. But unfortunately, the benefit doesn't come so soon. It will take, if we follow our research of the history of technology, maybe average time is 15 years, 5 years. So maybe society cannot wait so long time, so they will forget about that, or sometimes they blame that. But only when researchers continue to study long time, 15 years, 20 years, then they will have some sort of a reality. And this is very difficult time for researchers. They must, sometimes they must receive some kind of blame from the society, or they are forgotten, etc., etc. So I think they cannot get enough amount of money, or sometimes, unfortunately, those researchers who conducted within this nightmare research, they cannot have a good positions at universities, etc., etc. So I think this is a very bad time. So I can call this a nightmare research period. So this is some kind of a typical process of science-based innovation. So it is very necessary to care. And this is just an example. Very simple, I would like to say. This is a very old story, but you know computer-aided design, which is one of the specialists of Professor Su. And Mr. Sutherland opened an idea about computer-aided design. It was 1963, I think. It was very old time. The computer's facility is very low. The capacity of computer is not so good, etc., etc. But they showed very interesting concept and show a very example, very simple example, that manipulates the geometrical shape, geometrical figures within the computer. So those figures can be rotated, and the central gravity, the center of the gravity can be calculated immediately, etc., etc. And it is very good for designers or people who draw figures. So, and at the same time, in this conference, 1963, Mr. Sutherland, one colleague of Sutherland mentioned that within 5 years, the drafting board will disappear from the world, and every designer will utilize the computer display. But of course, after 5 years, we had no computer-aided design practically, and it took more than 20 years. It was, I think, 1980s, 80 or 90, that the practical computer-aided design has been utilized by companies. So there's a very strict reason. The manipulation of geometrical shapes within the computer is very difficult. The geometrical shapes are analog. So I think that if you try to calculate the intersection of two planes, there should be some sort of error, even if it is very small. So if you continue many times the calculation, the error will explode, and the geometrical shape within the computer will be destroyed. So it is very necessary to develop some special mathematics to maintain the error as minimum, as small as possible, or direction to eliminate the error after some times of calculation. We need some sort of the very complicated mathematics for that. But unfortunately, in the time of 1963, there was not such kind of mathematics. So concept was very good for computer-aided design, but from the practical point of view, it was not possible. So that is very difficult. We need more and more scientific knowledge to make a practical computer-aided design at this time. So there are many kind of nightmares. So in this case, I have mentioned about the computer-aided design. This is a lack of basic science, that is mathematics for geometrical manipulation within a computer. But if you look at the home robots, It is already said, 20 years ago, we shall have home robots. We have developed industrial robots which can act very efficiently within factories to manufacture motor cars, etc., etc. Now those robots will come into homes to help people to make some cooking, etc. But now we have no robotics within our homes at all. But the reason is very simple, because we cannot say the exact requirement for the robotics. So in the case of home robots, because of the lack of correct requirements, we cannot yet develop the correct one. There are many, many other different reasons. But anyway, when we try to develop something new, which is based upon some kind of new scientific knowledge, there the researchers should meet very difficult time, which is called nightmare research time. And let me say, the last one is very important. As Professor Su mentioned a few minutes ago, now we are confronted with a very difficult time, that is the sustainability. So we need something new product which is compatible, or which is good for sustainability age. And this is quite different from the present one. If you look at the motor car, we need a motor car without exhaustion gas. But it is very difficult to do that. So I think the sustainable product is now highly required by society. But in the case of designing or manufacturing such kind of sustainable product, we are confronted with increase of scientific domains involved. So it is not possible for us to design a sustainable product within a discipline. We must integrate different disciplines like mechanical engineering, electrical engineering, material science, or sometimes bioscience, etc., etc. So integration of different disciplines are very important. So in that case, the thinking mechanism of the human will become very difficult. When some researchers is thinking within her own discipline, it is easy. The physicist can think very efficiently within a physical discipline. But if he or she must think about the biology, suddenly it will become very difficult, and the efficiency will be suddenly very low. So I think in this case, the combination of different disciplines is obligatory for producing new products like a sustainable product. In that case, the efficiency of thought process will become very low. So that is the reason of why it takes so much time to clear the nightmare time. So I think a nightmare time is normally a very common thing. So I think from that point of view, maybe desirable investment from government, for example, the investment should be given to this area, but unfortunately, the present government policy is normally looking only in here. So the government people or political people forget about the importance of nightmare research. So they can seldom get the good research money in this area. So what we have done in our research institute is the full research. So I'm now in National Institute of Advanced Industrial Science and Technology, and which have almost 3,000 researchers, and plus some postdoctoral fellows, 500, and visiting fellows, etc., etc. And the total researchers, almost 8,000. It's a very big one. And the fields of research is from bioscience, nanoscience, and information technology and science, etc., etc. So very wide, but only aimed at contributing the improvement of the industry. This is the industrial research activity. And we have maybe the permanent researchers, there's 3,000. The 3,000 researchers are divided into almost 50 or 60 research units. And I would like to say the research activity should be something like this. So for this dream research activity, maybe almost university professors are conducting them. But of course, reality phase, that is a product realization, they are mainly within private firms. But as I have already said, the distance between universities and these industries are very far, and there is no bridge at all at this moment. So maybe we shall work for that. The National Research Institute, like AIST, should work for them. So in this research institute, we have 3,000 people, but 1/3 of them will be engaged in the dream phase research activity, and the second 1/3 will conduct about the productive realization, and the last 1/3 must work for the bridging them. That is a very important thing. This is a very important part of the research activity, but anyway, we can say, as I have already said, the thinking process is quite different. The thinking process in this area is quite different from the normal thinking process of research activity. So we can say this is the type 1 basic research, and this part might be called type 2 basic research, and the last one is something I cannot read. Sorry. So I can say, there are many researchers in here, so we can divide them into 3 parts, and those parts will be managed by the research institute like AIST.